Section 2.5 in college algebra is about more quadratic equations. So back in 2.3, we discussed solving quadratics through completing the square. But quadratic equations are sometimes in the form y equals ax squared plus bx plus c. That's called standard form. So we've got a variety of ways that we can solve quadratics. The first and probably the most common way for children to think of solving quadratics is to solve through factoring. That's where you write them as product of two linear components, set them equal to 0, and then solve. A second method that we saw earlier this chapter was completing the square. That was back in section 2.3. So we'll reference that a little bit today, but we're not going to necessarily do a ton of it. Another method is the square root method. Now, you're not going to be able to square root unless it's in a special form. Basically, the idea is there's going to be one variable present. It can't be an x squared and an x in the problem. So for instance, a problem that looks like x squared equals 64. That would be something that you would be able to square root both sides of the equation. Completing the square is technically square rooting. Just your job is to rewrite it in a format so you can complete the square. Another method is our old friend, the go-to quadratic formula, which you must have memorized by now. It's negative b plus or minus square root of b squared minus 4ac all over 2a. I know there's computer or calculator programs that can do this for you, but you're going to be required to not use those programs and yes, do it by hand. And I'm going to add a fifth method here, and that's our graphing calculator. Some of our quadratic applications are so disgusting that the thought of solving them by hand is really just not a good use of our time. So I'm going to show you what to do when you need to possibly look on the graphing calculator. So this first problem, 4u squared minus 8u, I think it's going to be set up in a nice way to factor it if I got it set equal to 0 or put it in standard form. So I'm going to subtract the 8u from both sides, and then I'm going to notice there's a common factor of 4u that I could take out, leaving me with u minus 2 in the parentheses. And then when I solve both of my factors by setting them both equal to 0, I get u equals 0 and u equals 2. Quadratics typically produce two answers, but not always. Now, number 2 is not in standard form. I'm going to subtract the 11x over and kind of rearrange it. My go-to method is factoring, and I didn't really look at the exam. Yeah, okay, we're supposed to factor all these. So, there's not a common factor to take out in this problem, so I just need to think about reverse foiling. Remember, f, in the middle is o plus I, and the last two multiplied together. So 2x squared would be a 2x and x, and then there's a few ways to get a 12. I might try same sign because of the positive answer here, but they're both going to be negative, I can tell. So I might try negative 3 and negative 4, but the placement of the 3 and 4 is crucial. I wouldn't put a 4 over here because that would give me a common factor of 2 that I know I don't have. So I'll try putting the 4 here and the 3 here. And I can check that by doing outer, which is negative 8, plus inner, negative 11. I have factored this correctly. So now I take my factors and I set them equal to 0. Whoops, kind of ahead of myself. And solve. So this one I would add 3 and divide by 2, so 3 halves. And this answer is x equals 4. The next problem is a little exciting because the first term is a quartic, x to the 4th. So instead of x and x, it's going to be x squared and x squared. And then adds to a negative 11, multiplies to a positive 24. Let's see, how about negative 8 and negative 3? Now when I set these factors equal to 0, I'm going to get the square root of 8, which will be plus and minus 2 square roots of 2. And then here, whoops, I'm going to add 3 to both sides and square root, and then I'm going to get plus and minus square roots of 3. And then number 4 is exciting. It's a cubic pattern. So when I factor the sum of cubes, the pattern is a plus b, a squared minus ab plus b squared. So remember the a and b are the cube roots of the first terms, the first and last term I should say. So a plus b for us is x plus 2, and then a squared would be x squared minus a times b is 2x plus b squared is 4. Now I'm supposed to solve this, and back in Algebra 2 you probably stopped at the factoring step for this particular question. You've never actually solved it. The first term is very easy to solve because it's just a linear term, x plus 2 equals 0, so x equals negative 2. Now this next part is a quadratic, and we're not going to be able to solve that through factoring, so the only way we'd be able to solve this factor is through quadratic, well, there's more than one method. We could use quadratic formula, or we could use completing the square. So since we just got done completing the square, I'm going to do that method. I'm going to leave a blank. I'm going to subtract the 4 and leave a blank. Half of negative 2 is negative 1 squared is 1. And that gives me x minus 1 squared equals negative 3. Now if you decided to solve this through quadratic formula, you're going to get the same answers. You get x minus 1 equals positive and negative. I can pull an I out of that. I squared is a 3. And my final answers are 1 plus and minus I squared is a 3. So if for some reason my instructions said only find the real answers, every time you have the cubic pattern, the first factor is the only real answer. The other two are going to be imaginary, as you see here. But since they didn't say any such instructions, I went ahead and did all of them. This next method, completing the square, we've done back in 2.3, but just to review. We're going to start by leaving a blank and adding the constant to the other side. And then what goes in the blank is half of the b term squared, so 9. And then we factor that trinomial into x minus 3 squared equals 12. Now we're able to square root. We get x minus 3 equals plus and minus. 12 breaks into 4 and 3, so that's 2 square roots of 3. And then finally my answers are 3 plus and minus 2 squares of 3. Okay, same method here on number 6. I'm going to move the constant over while leaving blanks. This time we have a negative 8 plus blank. Half a negative 4 is negative 2. Negative 2 squared is 4. We're going to factor this. And that equals negative 4. So now when we square root both sides, we have x minus 2 equals plus and minus square root of negative 4 is going to be a 2i. And my final answers are when I add the 2 over 2 plus and minus 2i. Okay. Since they want us to solve this one through completing the square, I'm going to. However, if it was my choice, I would not. The issue we face is that first coefficient has to be a 1. So we have to divide everybody here by an 8u. So m squared minus, I want to simplify what I can, so that is a 7/4 m. I'm going to leave a blank. I'm going to add the 3a's to the other side and leave another blank. Now, I'm going to do this off to the side. Negative 7/4 cut in half means that you're going to multiply the denominator by an extra 2, so it's going to be a negative 7/8. And then when I square that, I get 49 over 64. Whoops, 64. And since I don't have a calculator, I'm going to have to do a little bit of thinking here. Half of the b term would be, I think we decided negative 7/8 squared, and then 3a's plus 49, 64. So I need common denominator, so I'd have to multiply top and bottom, or numerator and denominator, by an 8. So that would be a 24 over 64. Plus 49 over 64, let's see, that's 73 over 64. I hope I did that right. And then we're going to square root. Sorry if I didn't. I have a feeling I made a mistake, but apologies. So we have square root of 73. The square root of 64 is an 8, so I'm going to go ahead and simplify that. And then when I add 7 to both sides, or 7/8 to both sides, I would like the answer either in this format, or since they now have the same denominator, you can write it in this format, which is the same answer that you would be getting when you complete quadratic formula. This is the setup that they like to see for quadratic formula, but either answer is okay. Speaking of quadratic formula, they want us to use it here. So formula is negative b plus and minus square root of b squared minus 4ac all over 2a. So the opposite of our b term is a 10 plus and minus b b squared. I like to write 100 instead of negative 10 squared because then I don't worry about typing any parentheses on my calculator, or at least not there. Minus 4 times a is 1, c is negative 3. And then big fraction bar all over 2 times a. So when you simplify quadratic formula, because we're not going to be interested in decimals for these types of problems, I want you to go ahead and crank what's in the radical into your calculator or in your head. This is 100, it'll be plus 12, so that's 112. And then I want you to reduce the radicals. So, oh goodness, I know that's divisible by 4. Let's see. Bigger, it's divisible by 16 apparently. 16 times 7. So this is really 10 plus and minus. If you thought of square root of 16 times square root of 7, that'd be a 4 square root of 7 over 2. And we're still not done because each one of these terms, 10, 4, and 2, can all be divided by a 2. So my new answer, most simplified answer, is 5 plus and minus 2 square root of 7. If you said over 1, that's fine, but you don't need it. The next problem is not quite in standard form, and you have to be in standard form to do quadratic formula, so I'm going to add the 3 over. Opposite of b would be 5, plus and minus b squared is 25, minus 4 times a times c, all over 2a. This one's shaping up a little nicer because I don't think we're going to be able to reduce, which is a good thing. 25 minus 12 is 13, and I'm a happy camper because that is the final answer. Alright, next problem. Opposite of b is positive 12, plus and minus. B squared is 144, minus 4 times the a is a 4 times the c is 11, all over, be careful, this time the a is a 4, so 2 times 4 on the bottom, or the denominator. 12 plus and minus, oh yeah, I need some help. 144 minus 4 times 11. Ooh, got to a negative 32. Over 8, excuse me. So negative 32 breaks up into 16, negative 1, and 2, which means it's 4i squared to 2. And then again, this is not a good enough answer because 12, 4, and 2 can all be cut by a factor of 2. So 6 plus and minus 2i squared to 2 just stays. Over 1 is acceptable, it's just weird, so I'm going to keep my answer like that. Okay, the discriminant. The discriminant is a portion of the quadratic formula. Let me write the quadratic formula over here real quick. The discriminant is what is located underneath the radical. And if you can find the value of the discriminant, you would know a lot about the problem. For instance, if you think about what's under this radical being a number that's greater than 0, that means you're going to be taking the square root of some positive number. I don't care what it is. But the idea is that you're going to have some number plus and minus some other number. You're going to get 2 real solutions. I'm not promising that they're going to be pretty solutions, but you will get 2 real solutions. Now think of the second case. What if what was under the radical came out to a negative number? So something like a negative 3. Well, that's going to produce i's in your answer, and because it's negative number, or a number, plus and minus some other number with an I in it, this time you're going to get 2 complex or imaginary solutions and no real solutions because everything will be imaginary at that point. And then a curious case is when there's a 0 under the radical. Well, what happens when you take the square root of 0? You get a 0. So what you end up with is some number plus and minus nothing. So essentially what you're doing is you're getting the same number twice. So you're only going to get 1 real solution. Let me talk to you real quick about what that looks like. If you have a case where you have 2 real solutions, you will have a parabola that will touch, or I should say intersect, the x-axis twice. So it doesn't matter where it intersects, but the idea is the parabola will have 2 obvious solutions or x-intercepts. Could, be upside down, could be anywhere. If you have no real solutions and only imaginary solutions, what you're going to see is your parabola never intersects the x-axis, and his solutions are purely imaginary numbers. And then one real solution is a special case of the graph. Your parabola is going to come down and touch the x-axis just in that one point. So it could look very different. Doesn't have to look exactly like this, but the idea is your one solution, the one place where it touches the x-axis, that has a multiplicity of 2, meaning algebraically that solution shows up twice. So let's go ahead and calculate the discriminant for number 11. B squared would be 6.4 squared minus 4 times A times C. So I'm going to grab my calculator and type, because I'm definitely not going to do that in my head. And I get an answer of, 82 point something. It really doesn't matter what I get, as long as I know if it's positive, negative, or 0. So that is a positive answer, which means I'm going to have 2 real solutions. It doesn't matter what the solutions are. They just want to know what they are and how many of them they have. So same thing for number 12. B squared would be, make sure it's negative 7 point, whoops, it's a 0.4, in parentheses, squared, minus 4 times A times C. And then when I type that in my calculator, I tend to just leave the negative off since I know I'm squaring it, which, it's fine. I get a negative 33 point something, blah, 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 blah. So that means that I have a negative answer, obviously. So I have 2 imaginary, or you can say complex, solutions. And you also want to make a note that means you have, 0 real solutions. So there's not going to be a single real solution in that problem. Okay, example 5. Using a graphing calculator, we are going to use a graphing calculator, so please grab yours. If you don't have one, watch what I do very carefully. Come on, calculator. Oh, I always press that. Back up. Nope. Try again. There we go. So in y equals, I want you to type in whatever function they give you. And we're going to want to find where this function equals 0. So essentially what we're looking for are the x-intercepts of this function. Now, tomorrow's lesson will all be applications, and we're going to see that sometimes, often, in fact, your quadratic, even though it gives you 2 answers, one of them is going to be extraneous for our problem, so we're not going to want it. Now, I always start in the standard window. If I could see the x-intercepts, I'm happy. I think this might be a special case where there is just one x-intercept. So what I'm going to do real fast is I'm going to calculate the discriminant so I don't waste too much time. B squared, I'm just going to put positive 3.2 squared minus 4 times 0.2 times 12.8. I'm just calculating the discriminant, and see how the discriminant comes out to 0. That tells me I'm just supposed to get one answer. Whoops. Come back. So back to my graph. If I can find the x-intercept by using my trace menu, or calc menu I should say, it's called a 0 even though it doesn't technically intersect. Left bound, I'm way up here right now, which is definitely left of him, so I'm just going to hit enter. And then I'm going to scroll to the right. There he is. I can kind of guess where I think this is, but just to make sure. The reason we often use a calculator is because the answers don't always come up beautiful. In this case, the answer is 8. So there's only one solution to that problem, and it's 8. So a little boring. Then I'm going to go to the next problem. X to the second power. And just a comment, if you know you have imaginary solutions, you will never be able to find them through a graphing calculator using these methods, because you can't see imaginary things, unfortunately. Now this particular quadratic has 1, 2 answers, and I think they're nice, and I can tell that because that problem is factorable. I kind of quick factored it in my head, and I know it's going to factor into x plus 8 and x minus 5. So logic dictates that that's a negative 8 and that's a positive 5. Sure enough, I'm right. Now if these weren't nice answers, you would have to do that second trace, 0 finder, yada yada. Now, you guys are excellent at finding all those. So I am not worried about that for you at all. And I guess that's lesson 2.5. There is a follow-up portion for 2.5 that's all applications, and in that packet we're going to be talking about how to use our calculator very strategically and also how to eliminate some extraneous answers. So good luck.